Good evening, everybody, and welcome. Thank you so much for joining us. I'm Chris Holen, and I'm the Chief Conservation Officer here at the National Aquarium, and we are excited you are here tonight for this evening's lecture, which is part of the Marjorie Limbanks lecture series, Changemakers, Making Conservation Personal. That is our theme for this year. And throughout this series, we have really been honored to bring to Baltimore individuals who have devoted themselves to creating positive change, be it to address climate change and promote resiliency, or to improve ocean and human health, or build needed diversity in the conservation space. We believe their stories and insights and inspiration can serve to be both inspirational to us personally and professionally, as we all seek to make change, leave a legacy and make this blue planet a better place for all of us. So the Aquarium has had the pleasure of hosting the Marjorie Limbanks lecture series now for more than 15 years, thanks to the generosity of the Bank family. And as many of you know, Marjorie was a photojournalist, she was an environmentalist, diver, and explorer, and when she passed away in 1994, her family endowed these lectures in her honor. And it has really been deeply gratifying for the Aquarium to play a part in sharing Marjorie's love of the ocean and her sense of adventure with a community that is very like-minded. So in addition to recognizing the Bank family for tonight's event and making it possible, we'd also like to acknowledge the entire Aquarium family of both members and donors, because we could not do any of our work without our members and our donors. We could not connect people to the aquatic world through our exhibits, through our education programs, our conservation initiatives, and more. So I really want to say thank you to everybody who is a donor or a member. And, I have to put in the required statement. If you are not a donor or a member and would like to become one, we can certainly help you. And it is really a charitable cause, and we would encourage you to speak to any one of us. But I'd also like to acknowledge the National Aquarium staff and volunteers who are here tonight, because we could not do any of our work without the staff, but particularly without the volunteers. It takes everybody, and we have an amazing team here at the Aquarium who care very deeply. So with that, I want to say thank you to our volunteers, because I think we have a lot of volunteers in our audience tonight, so thank you. And as a special treat tonight, we also are welcoming the inaugural Youth Climate Action Network, and we call it our UCAN program. And UCAN is taking place this week, where we brought together, it's our Urban Climate Change Action Network, where we brought together participants from Baltimore. Baltimore team, raise your hands. Yay to Baltimore. We also have Chicago, Illinois team. All right. Orlando, Florida, those kids, yeah. Only two more. Powhatan, Kansas, where are you? Yeah, be proud, be proud. And we have a team from Pago Pago, American Samoa. Yeah, there they are. And our UCAN program is a new program. It's conducted in partnerships with the American Planning Association, the National Religious Partnership for the Environment, and the Antarctica Southern Ocean Coalition, and then, of course, the National Aquarium. And I will say, that is not a list of partners that you typically see working together, but it just is indicative of the fact that climate change takes everybody. So it's not working, so I'm just talking to myself, which is a frequent thing for me to do. So that is of absolutely, so could we turn it on? It was on. I was actually looking at the man up in the booth. All right, I'm going to continue, because I actually do, as my kids will tell you, I have a very loud voice if I need to. So the UCAN program is designed to empower teens, particularly those from communities most affected by the impacts of climate change, to connect with peers in other cities and to discuss environmental, social, and economic challenges. And to take action in the places where they work, live, and play. And so I think Zack will probably be the highlight of their week. And we may have then, as a result, many more Zacks in this audience tonight. So that's exciting. Which brings me to Zack Rago. He is our tonight's guest. He is one of the co-stars of Chasing Coral, which is an award-winning documentary which visualizes the plight of coral reefs in the age of climate change. And Zack helped to build, as many of you have probably seen Chasing Coral, and if you haven't, I'm sure you're going to go out immediately afterwards because it's an amazing film. He helped build the unique camera system that was used throughout the film. And he is one of the people on screen telling the story behind the waves. So Zack, actually, I don't think, and he'll probably mention this when he talks to you, he did not intend to be necessarily in the documentary, but he is actually one of the main stars of the documentary. So it's really a treat to be able to have seen the film and then to see someone that was so close and actually on the screen. But Zack, now, after the film's been out for, now we're back. Now you're in trouble. You'll hear lots of, now that might be a little too much. Zack now works, and we're going to get this all straightened up before you get on stage, Zack, which is part of the key, too. So this was all planned. Zack now works as a youth outreach manager with the Chasing Coral Impact Campaign to engage the next generation in marine conservation. He is a passionate science communicator, which is really the whole purpose of the film. If we're going to, we can be all the scientists we want, but if we can't communicate it and effectuate change to people, then that's what we need is science communication, and that's what this film is about, and that's what Zack does so beautifully. He is also a self-proclaimed coral nerd, and he is from Colorado as a coral nerd. I don't know how many people are in your club in Colorado that are all coral nerds, but you can let us know. He is an aquarist, and he works with the nonprofit Teens for Oceans. He also worked with the underwater camera company View into the Blue, where he actually became involved in this project, and he can tell you how that happened. He holds a BA in evolutionary biology and ecology from the University of Colorado. And so now the sound system is complete, Zack. We are ready to have you come up. I mean, it's a real treat. I think you all are going to be so inspired and engaged by Zack. And if you have questions, we'll be having a dialogue afterwards with Zack. You all should have cards. You'll be able to hand in cards as when we get to the discussion point. So with that, Zack, come on up. Come to the microphone.
All right, well, good evening, and thank you guys for being here. I hope that this is going to be a really engaging conversation. It's going to be a lot of background into my own life, into the film, but more importantly, this talk is going to be around what I learned through this entire journey. So a brief picture into what happened to me back in 2014. I was a 21-year-old kid. I had really no experience doing much other than growing coral. And I somehow met a very interesting person who ultimately made this documentary. I was never supposed to be on camera. I was literally a kid that was supposed to go diving and put cameras in the water. And yet here I am now. And I've learned a great deal along the way. And that's really what I want to share with you guys. So let's back this up for 10 years, 15 years. And I want to tell you a little bit about how I got here and how somehow I was prepared for the opportunity that I was given. So when I was 12 years old, I got my first aquarium. It's very nice to be in an aquarium, to be doing this, because I absolutely love them, and I think that they're one of the best educational opportunities that we have. I absolutely love coral. I literally have never had fish in my coral tanks. I just don't go there. It's corals and corals only. I find them to be the most fascinating things on the planet. They're unlike anything else that you can find, especially when you look into the symbiosis of them. But this is what I did for fun. I made a legitimate living off of doing this, and it made me really happy. But at the same time, I learned a great deal about the corals. I learned the taxonomy. I fell in love with being able to identify what's in my tank, and the fact that nobody else really knew what was in there. That's what got me going. And I still to this day can get absolutely jazzed about not being able to identify something. This is my current tank. This was taken just a few days ago, actually. I have about 60 species in my office. I still go through with this, and that's something that's really important for me, is this was my roots. My roots were in the aquarium industry, and I still go through it because this is my happy place. Beyond all the chaos that my life has become, this is my place where I could just go one-on-one with my corals and have a little piece of the ocean in my office. However, the aquarium industry has a little bit of a dark side. I think we all know that. I think that the aquarium industry can be frowned upon a little bit, and that was part of the reason why I left. But the other part of the reason why I left was a conversation that I actually had with a coworker of mine while I was working in the aquarium industry. And for those of you that haven't seen the video, which I don't have, but I have an image, I was watching this video. This is a guy named Kevin Richardson. He's known as the Lion Whisperer. So there's this GoPro video online that came out, and this guy does this. He's out in the middle of the wild, and these lions, he has this intimate relationship with. And I thought it was so fascinating, and I got into this conversation with my colleague about how could we ever humanize corals, or really anything in the ocean for that matter, in the same way that Kevin Richardson did for lions. But even taking it a step further, one of my all-time idols when I was a kid, I love her to death, was Jane Goodall. She did the same thing. She changed the way that we not only think about primates, but the way that we've positioned ourselves into nature. And so we had this amazing conversation, and unfortunately, it kind of ended in this acceptance of, well, I don't really know if we could do it for corals. They are these stationary organisms. They're rocks, essentially. They're also plants. They're also animals. They're very odd. They do not have that much in common with us when you look at them in a picture. But when you really dig into them, it turns out that they're just as much of an animal as you and I are. They eat, they fight, they reproduce. They do all the things that an animal does. But this conversation ended there, and it would be a good amount of years before this conversation even popped back into my head. We're going to get to that a little bit later, but I want to start this with the sense that humanizing and storytelling are at the core of what Chasing Coral was, and that's not something that I personally understood or even accepted when I started this project. So when I moved on for the aquarium world, part of my goal was to begin this journey of how can I get people more invested into the ocean? How can I cultivate the relationship that I have in others? The first thing that happened was I got a job with this crazy man. His name's Trevor Mendel, but he runs an organization called View Into the Blue. He also runs a nonprofit called Teens for Oceans. The idea behind it was these cameras that we made. The cameras were actually quite brilliant. Anybody that works in the aquarium world knows that things get dirty really quickly. We wanted to change that. We wanted to be able to bring imagery, live imagery, to anybody. And so in order to do that, we had to find a way to clean the cameras and leave them underwater for long periods of time. And that's what we did. And we had a great deal of fun doing this. The idea being, well, most people don't have an opportunity to get into the ocean, let alone dive, let alone snorkel. How can I allow Joe Schmo from the street to be able to engage with coral reefs? Well, I can provide them live video from a coral reef in Grand Cayman, like this. This was taken not too long ago. It's a reef camera that I've had for 7 years. And there's stingrays swimming around. There's corals, there's life. This is a cleaning station, actually. So you can see these fish come over this colony of coral and get cleaned up by cleaner shrimp or by cleaner wrasse. And it's fascinating. It was our way of engaging, most importantly, youth who would come out and put these cameras in the water with us. But more importantly, anybody could go online and have a little piece of the ocean. They could get a little bit more related to a world that is so far out of sight and out of mind that we just don't think about it every day. However, when I started this job, this guy walked into my office. His name is Jeff Lasky. This is him. And he flipped my world upside down. Again, I was 21 years old, no idea what I'm doing with my life, but I was diving most weeks, months. And he came in and he said, you know what, your technology that you have, I think could be really useful for something that I want to do. I had actually known of Jeff Lasky already because I had seen his previous film. He made a film called Chasing Ice. The concept behind Chasing Ice was you have a phenomenon going on our planet where glaciers are melting all over the world. However, us as humans with an all-time low in attention span, that doesn't mean a whole lot to us. We go to the glacier, we come back a year later. Does it really look all that different? Does it matter? But what he did is he manipulated time, and he utilized time-lapse technologies to show us this, to be able to allow the human mind to grip a phenomenon that lives life in the slow lane. And he ultimately pulled this off. It was really the first visual representation of climate change that we ever had. The film showed in front of the White House, in front of the United Nations, in front of Congress. It was impeccably important that this film came out, and it shared a story that none of us would be able to grasp unless we had the imagery alongside it. So what did he want from me? Well, it turns out that there were a lot of pressures and issues going on in our oceans. And a man named Richard Vevers had sent Jeff an email after watching Chasing Ice. Attached to that email was 2 photographs. This photograph of an impeccable coral reef, really great health. You can see the structure of it. And he sent a second one. And it was this. And it doesn't really even take a scientist or a biologist to know that that's a really large difference. Something is wrong in those pictures. And Jeff immediately said the light bulb goes off. And he says, well, we can actually document this transition. Once again, another visually representable change that's going on in our ecosystems, on our planet. Let's go out and do it. One problem. It's literally impossible to take a time lapse underwater long term because of the biofouling. Well, I just so happen to be able to fix that problem. We're the only company that can do it. And in he walks. He proposes this idea, and we immediately get to building these cameras. A totally custom job, different than anything that we had ever built, but it was a lot of fun. And you could see that in those previous pictures of Trevor laughing. And we had a great deal of challenges, but a great deal of fun that went alongside of it. Before we move on, I do want to talk about the actual phenomenon that we were trying to battle. So corals are under a great deal of stressors right now. It doesn't matter if it's bleaching, ocean acidification, overfishing, sunscreens, there's so much there. We had to determine what are we going to document that would allow us to be able to have a film, be able to express to the public why corals are important and why they're so fundamentally challenged right now. So what we did is we looked at coral bleaching. So this is a little diagram that I want to use in order to do a little debrief on what exactly coral bleaching is. This arrow is pointing to an area that almost looks textural, so you can actually see lines going through that coral colony. These little lines of color are actually zooxanthellae, or it's a type of dinoflagellate which produces the energy for the coral. A coral is an animal. It has these tiny plant cells that live inside of it, and it produces a rock. It cannot produce that rock without plants. So that energy that it's getting from these little specks in this image is absolutely essential to the coral's survival. There's a catch. These little plants do not like being too warm. When they get too warm, they actually disappear. And you can see in areas of this particular coral, you don't see that same pattern. You see a lack of symbionts, a lack of algae, and that area is stressed. That change from the colorful area you see on the left to the right-handed side where there's not any more zooxanthellae, that's what we call bleaching. But that transition is what can be visualized for climate change. It's what, if you manipulate the time, you can actually do something with it. And what that looks like is something like this. This is a picture taken by Richard Vevers in American Samoa. I know we actually have some people here. This is Airport Reef. This first picture was taken in December of 2014, and this picture on the right-hand side was taken in February of 2016. This is 2 degrees in temperature change, and you can see this drastic shift. But more importantly, it's visual. Once again, we're telling a story. The science doesn't matter, because what's happening right here is something that anybody with no training can just look at and tell you something is not right. So why did this happen? What was the background to what we were able to do? And why were we so lucky that we decided to do this project at the right time? Well, this is why. This is a diagram of the largest El Nino events that we've ever seen on this planet. An El Nino event essentially means that most of the water in the Pacific is warming more than usual, particularly towards the Americas. 1998, 1997 was the first time that we saw a mass coral bleaching event. This happened across the globe. We lost a great deal of coral. We also had a lot of mortality. But we didn't know anything about it. This was our first intro to a phenomenon that would ultimately start happening more frequently. 2015, it happens again, this time much worse. But we didn't plan for this. We started this project in 2013, 2014, and we had an idea that we were going to go out and we were going to try and capture corals that were healthy, turn white. We had no idea what was in for us into the future, and we had no idea that this El Nino event was going to ultimately come and rock the planet. So we had a game plan. We wanted to capture this, and this is a map of Australia in the previous bleaching events. So if you're like me, you're gonna look at this graph and you're going to say, well, down here at the bottom is where it historically bleaches, correct? So raise your hand if you were me in 2015 and you had a bunch of cameras that you had just spent a great deal of working on. Where would you put those cameras? In the south, right? So that's what we did. We ended up putting our cameras all the way in the south. That's where our permits were, that's where everything was. We thought we made the right decision. As a scientist, usually failure ultimately leads to the better discoveries. And this is the truth. Let me give you an example, actually. When you think of an anemone and a clownfish, for instance, let's take away all of our predisposed notions of this and say, I give you an anemone. We look at it under a microscope, we see stinging cells, we see that it looks pretty harmful to anything alive. Now we say, let's go into the ocean and let's make a hypothesis. Let's say, well, there's no stinging, or there are stinging cells in this anemone. I'm going to assume that nothing lives inside of it because it's going to die, because it's going to be stung. We go in, we actually observe, and what would we find? That almost every anemone on the planet has a clownfish in it. Now we failed. Our original hypothesis was wrong, but we have a way cooler question now. We ultimately find out that they produce a glucose molecule that tricks the anemone into thinking that it's part of itself. The anemone recognizes the clownfish as its own tissue. And that's a fascinating question, but we wouldn't have gone there without failure. So again, I put my cameras in the south. And that's what happened. It was really brilliant, and it was heart-crushing. So you can imagine, I have 5 cameras now in this pleasant green zone in Australia, and I've worked for a year and a half to make this happen, and all of a sudden, nothing is going to happen. And I don't have the permits, I don't have the resources to move these cameras up into that northern section. So we had to make a really drastic decision, and the funniest part about this decision, looking back on it now, is there's a meeting that's on video. It never made it into the film, but there's a meeting in my office in which all of us unanimously agree that it's absolutely outrageous to think that we could go camp on the beach and dive every day for 2 months and take the same photos over and over and do manual time lapse. Well, that's what we did. We had to make a really drastic decision, but it was rooted in failure. And for those of you that haven't seen the film, the storyline of this movie comes from the fact that we failed over and over and over again and ultimately had to do it ourselves. And that's really important because just like how science, failure usually leads to the discoveries, well, in storytelling, you let it tell itself and you allow the story to take you with it. And you know, if it had bleached in the South, I don't think that our film would have been that great. I think that the fact that we had to do it personally, that me as a dedicated coral nerd had to get in the water and watch something that I love die every day, that ultimately made this story worth sharing. It ultimately is the reason why I'm standing here right now, is that I've experienced something that really nobody else has had an opportunity to outside of the scientific community, and now we have an opportunity to share that. And the personal experience is going to go farther than the numbers and the data and the graphs ever will. So before we continue on, I want to show you what that time lapse looked like for those of you that haven't seen the film. We dove for 45 days straight, every single day, the same exact sites, and this is ultimately what I watched every single day. So 55 days surpassed in that video. Most people would look at that and give me an answer of a year or a couple years in which this transition took place. We're talking about 95-degree water in this lagoon, conditions that corals simply can't cope with. It was more enjoyable for me to be out of the water than in the water from a temperature standpoint. It was more refreshing to get out of your dive than in your dive. That is not what the ocean is supposed to be like. So how big was this event that we're talking about? In the film, we talk about Australia, and Australia was damaged heavily, and we're going to talk more about that. But this was a global scale event, and unlike 1998, and unlike 2010, and unlike 2002, this was a 3-year back-to-back-to-back bleaching event on most places on the planet. And this graph represents the heat content that was there for those 3 years. You'll see on the legend at the bottom, you see that no stress. And what do you see that's the most daunting piece of this image that was produced by NOAA is you will not find a single speck of no stress on that graph over that 3-year period. There was not an area on this planet that was suitable for healthy corals to be thriving during the past 5 years. And that's a really daunting fact. That's something that hits you in the face. That is one of the scariest things for our marine environments that could have happened is happening right now. And we need to tell stories about it. That's what's so important about this project. And that's what ultimately led me to continue the work that we're doing now, which is reaching out to youth, getting people more politically involved, and making sure that the scientists that are ensuring the longevity of these ecosystems can continue to push on. And so what I really want to talk about through the next 30 minutes or so is I learned a great deal throughout this process. I was trained in science. I didn't know anything about art. I didn't know anything about film. I didn't know anything about photography. I didn't know anything about the power of storytelling. And I had a lot of misconceptions about science. The number one thing is that perspective is everything. When I look at this photo, I see something drastically different than you guys. Does anybody in the audience want to shout out what they see in this photo? Anybody know a species name or a common name? Anything? It's a staghorn coral, absolutely. But when I look at this photo, I see very abnormal polyps. And this happens to be the first newly discovered coral on the planet in over 30 years that Charlie Varon and the team that I was on discovered last December. So when I look at this, I see something different. I've spent a great deal of time looking at corals, and I see them a lot differently. I see things like this. I can see their movements. I see them, their mouths opening, their polyps expanding during the day, and they're fascinating. But unless you take the time to really look at them, you're never able to capture it. So again, everything on this planet lives life in the slow lane. And that's the number one thing that I took away from this is if we want to communicate things like climate change, particularly for all of you students up top here, you have to start with common ground. Even though you have all the numbers and statistics in your head, you got to give people something to work with. You have to get them connected to it. You have to allow them to be a participant in what you're talking about because nobody wants to be told what to do. And unless we can see from the perspective of the world, then we have no chance. We have to truly be able to communicate in a way that the animals themselves would do. And that means we have to go slow and we have to manipulate the way that we look at it. And that's extremely important for me now, looking back on it, that I was able to see these things, but until I got involved with film, involved with art involved with this bridge between two fields that we so desperately want to separate, I didn't really see that we had this opportunity to utilize the most powerful tool that we have left, and that is using science and art one-on-one. The other big thing that I learned was that corals are not just facing coral bleaching right now. The problems they face are absolutely endless. But the most daunting one for me, working in some of the most remote places in Australia, was the trash. No matter how far away you get from the mainland or away from the nearest city, trash is there, and it was mind-boggling to me that there could be no footprints in the sand, but there's still going to be bottle caps and rope. And no matter where you go, it's always going to be there. This is in the British Virgin Islands. This is on one of the most remote beaches I've ever been to. This is a 16-hour boat ride away from the northern coast of Australia. First of all, people don't really live there, but we see things like the backbone of how you make flip-flops. This is the plastic that they cut flip-flops out of, somehow ended up on this small island in the middle of the Torres Strait. Or hard hats ending up on beaches that people haven't walked on in years. Or this. How does this even end up on a beach? It's mind-boggling to see the amount of trash that are in these remote places. But more importantly, we're finding now today that we are in the best possible position to be getting rid of these things. We see it all the time, whether it's Starbucks and these multiple airlines over the past few months, or I recently heard this morning that Baltimore has banned plastic bags in recent months. These are all fantastic steps forward, and it's perspective of where we're headed, because this is where we have to be. We cannot any longer have this notion of waste. We can no longer have this notion of devaluation. That plastic is worth something to somebody, and it can be used for so much more. We need to be better. And plastic in itself is part of the problem. It is a petroleum-produced entity, and it is immediately impacting the corals because it's plastic, but more importantly because of the oil and the resources that went into it. Now, my favorite part of all of this is the science communication gap. I've been really lucky to meet some of the most amazing minds in marine biology through this entire adventure, and they're not the best communicators. Most of the time, listen, it's so important to think about it from the perspective of science. They're designed to be objective. They think so much differently than the rest of the world, and they have such depth of knowledge into their subject matter that they get really excited. It's just like me. If I want to talk about corals, you're going to see me light up like a kid. There are people out there that study E. coli, and you approach him and you say, hey, I want to talk to you about E. coli, and you will see them light up like a little kid, and they will have the most enthusiastic conversation about you with bacteria that they've ever had. At the core of being a scientist is full commitment and love and joy for your subject matter, and that's what all scientists share, but they're not good at sharing it back to the average person who aren't on the same page as them. That's really tough, and part of the problem is us. We desire black and white no matter what. It's the way that we work. We love to categorize things. I enjoy taxonomy. That's at the core of taxonomy is you're a species and I want to put you into a bucket and make sure that you are what you are. Corals don't necessarily follow that to the nail that everything else does. A coral that looks one way in Australia could be genetically identical somewhere else and look remarkably different. That's what makes them so cool and what makes them a gray area. So, for example, in our black and white, in our media, in the way that we communicate science now, we've got polar opposites all of the time. We've got an obituary written for the Great Barrier Reef in 2016, which simply is not true. There are still really majestic places all over the planet that are perfectly healthy, that are fairly untouched. The Great Barrier Reef is not dead. I've been to some of the most spectacular places I've ever dove after these bleaching events. And on the other hand, we have Australia's Great Barrier Reef is not being killed off because of global warming or any other allegedly man-made non-problem. The people who know best have confirmed that's also not true. There's a great deal of hurt and degradation going on in Australia. Everything is a gray area. And to prove this, we actually went out on an expedition. I work with a company or a nonprofit called the Great Barrier Reef Legacy. And we went out and we wanted to do the first survey work after these bleaching events to be able to take that black and white notion and come back and tell people the truth. With no boundaries from government or no boundaries from media, we were just a group of scientists that wanted to go out, look for ourselves, and tell the truth. So when we went out, we have expectations, right? We just talked about how the northern section was hit extremely hard. So our notions are that we're going to see absolutely dismal reefs in the north. On the outer banks, we might see a little bit more because they have access to cooler water, cool them down, get that heat away. So we went out and we asked the question, well, what are they going to look like on that outer bank and what are they going to look like on that inshore reef? Well, it turns out that expectations are usually true. This is the Inner Reefs on Australia. This is a pretty cliche image of what most of the Inner Reef looks like right now in the north. This is 99% mortality. I can see a little bit of coral growing here and there, but this has been devastated in 2016. There is not much life living on this reef. Most reefs look like this right now in the Inner Reef. However, everything is a gray area. We also swam in an area that looked like this. Should not be here. It's on the Inner Reef. It's in a mangrove system, obnoxiously hot water. Because there's mangroves, it's got a fairly low pH. Corals should not be living here. Yet this coral reef had about 100% coral coverage and was absolutely flourishing with life in an area that it shouldn't be. This is why everything's not black and white. This is why the Great Barrier Reef is not okay and it's not dead. Everything has its own story. Every reef has its own story, and we need to talk about them that way instead of bundling things up into dead or alive. Let's protect the areas that look like this and not fight the battle that's too far uphill on the coral reefs that have been degraded. Now, this is where it gets really surprising. My expectations for the outer reef were not much better. I assumed they were going to be semi-healthy. I assumed we would see coral. I did not expect to see this. This is one of the most diverse locations that I've ever seen. When I got out of the water, I felt like I had just dove in 1965. And Charlie Varon, who I was with, who is historically pretty pessimistic dude. I'm sorry, Charlie, but he is pretty negative about the current state of the Great Barrier Reef. And when I was underwater with him on this dive, I have never seen that man as giddy and childlike as I have here. And that alone should give people hope, because this should not exist either, yet it does. This is likely the most diverse acropora site ever found on the planet, and it's found in 2017 in the northern Great Barrier Reef. Miraculous. And we need to do everything that we can to discover more about why it is that way. In fact, we found a coral on this reef that was about 900 years old. This is the top of it. This coral was about 20 meters or so in height, and it has a microcosm coral reef growing on the surface of it. Amazing. It's one of the coolest things that I have ever seen, and it's pieces of coral and pieces of our ecosystem on this planet like this that ultimately keep me going and give me more hope. However, again, nothing is black and white. This is just a little bit north of that same reef, and it did not fare as well. It probably has something to do with the hydrodynamics of the area. Something is going on in these places that allow one to flourish and one just neighborhood over not to do so well. So we need more research. We desperately need to be talking about the ocean more and more, because the funding that comes from nonprofits, that comes from philanthropy nowadays, that's where we need all of our resources going, is to find out why this can end up that way and why this can end up this way. It's impossible for us to move forward for coral reefs without understanding at a local level what makes something special, what keeps these gems going, and how can we protect them. Now, to keep going into this notion of black and white beyond just the corals, most people aren't super interested in the corals, and I am fully aware of that. So I like to talk about the human side quite a bit too, because chasing coral is a human story. As much as it was a transition of corals and a transformation of corals, it was a transformation for me too. But one of the biggest things that I learned was we talk about science foundationally wrong. This is the type of picture that we see in science. This is what kids are shown in science. Very objective. Even though you're on a beautiful reef, it's a very objective photo. You've got a diver who's taking notes, who is fully immersed in the objective nature of his work on that reef, or a meeting mapping out what reef we're going to go to the next day. We've got a lot of serious faces. Usually it's accompanied by white jackets and some beakers, which isn't usually the case either. But this is what we're shown. We're shown numbers, graphs, objective nature to science. And we continue to see it. Yet this is what science is. This is what we're doing underwater. Sure, there's objective, and sure that there is a sense of seriousness to get your work done, to fulfill your career, but we have a great deal of fun. This is that same coral that we just talked about, 900 years old, and my colleagues were so stoked. We were so excited. This is one of the coolest finds that we had ever had. It is now a candidate for being cored so that we can learn into the past of this coral. But this is what we're talking about. It's the underwater high fives that we need to be telling kids about to go get involved in science. It's the finding that unbelievable species in the water or in land that keeps you going. And every now and then you get a slate underwater that looks like this. It's absolutely amazing what can happen in science. And what we're not telling the youth in particular is that science is not about the numbers and all of that. It's about how stoked you are to be surrounding yourself with people that share the same ideals as you, that share the same interests and are as passionate about something that you love that you are. And you can be on a boat for 30 days and enjoy the absolute heck out of each other, all while making the thing that you care about a better place and learning more about it. That's what science is, and everything else is secondary. You do not become a scientist or get into that field or go on these adventures unless you absolutely love what you're doing. Now, there is a lot of reason for hope, and I think that at the core of that is you guys sitting in the back row up there, and photos like this. Youth are going to take this challenge head on. We're already seeing it in today's world. The millennials are already willing to put their money where their mouth is, and they're not made out of money. They're willing to spend that extra dollar to put towards companies that share values with them. But we also can see that the science is telling us that corals can have an opportunity to survive. And it starts with images like this. We're talking about hundreds and hundreds of feet of coral that are dead in this picture, but that one little area that survived, that's what's meaningful. That little 1% or 10% that's going to make it through, they are the future. And because corals reproduce in the fashion that they do, in throwing their gametes into the water column and then drifting wherever they want in the ocean, they can actually reseed themselves. They are fundamentally their own seed banks. And areas like this are those seed banks. And what does an area like this do to the area that was just north of it, that was degraded and basically uninhabited by any other life? Well, you get things like this. This is the single most hopeful picture that I have ever taken. This is a reef that was absolutely decimated. And you have 5 brand new corals, all different species, in the size of a cell phone. These are brand new. They're a year old after the worst bleaching event that Australia has ever seen. And all of a sudden, they're back. They're able to replenish themselves and recoup the areas that have perished in the not so distant past almost immediately. And that is extremely hopeful. So what are we doing with these corals, and how are we going about ensuring their longevity? Well, not only is it this, but it's also taking care of the parents. Part of the notion of what we did with Great Barrier Reef Legacy's search for supercorals was to find supercorals. We collected all of these specimens from reefs that were essentially dead. Now, think about it. How do we get things like corn or peas we've selectively bred them over time to produce something that we desire. The idea behind what we're doing with these corals in Australia is, well, if I take the only survivor from this reef and I force it to breed with another only survivor from another reef, well, its children are more likely to survive. So now we have baby corals that we can actually put back onto the reef, but now these baby corals are actually prepared for the future. If mom and dad survive, the kids should survive better as well. That's the goal behind what we're doing and what Great Barrier Reef Legacy is doing. But more importantly, it's giving us insight into how we move forward with these reefs. And what I think is so fascinating, and which I talked with a lot of you beforehand, is we can no longer focus on the ones that have died. We need to protect what we have, because at the end of the day, we're going to lose about 90% of coral reefs around the planet. The 10% that's left over, they are what's important. We can no longer cost effectively put corals back onto degraded reefs. We have to protect the ones that are going to ensure the future and allow us to cultivate seed banks. The reefs that don't bleach, the reefs that have been set aside, so to speak, and have been extremely lucky over the past couple decades, those are the reefs that we need to put all of our attention on. And we can no longer do that if we continue to put corals back onto reefs that are doomed. We need this type of science, and we need the next generation of scientists to go out there and to start protecting rather than restoring. Sure, restoration is an impeccable thing that needs to continue to happen, but protecting what we have and what can continue us into the future is really where we stand. And so this baby coral is what gives me hope. And in the same sense as the young, youthful corals give me hope, it is the next generation. What is so important in today's world, and why I'm so excited that this talk has coincided with the UCAN kids and students and people in this room that want to change something, is that we have an opportunity right now to inspire the next generation. And that's through storytelling. We have to inspire them through virtual reality. I can go into Denver, Colorado, where I grew up, and take kids that may never see the ocean, take them on a virtual dive, and share with them something that is beyond their grip, beyond anything that they may ever have the opportunity to experience. And you can inspire the next generation of people that are going to be the decision makers, the people that are going to be on the ground doing the coral research, or the next climate advocate that's going to make a splash down the street in DC. This is where we have to be moving. We can no longer just focus on the science. We can no longer just focus on the politics. We have to get the youth involved, and everybody has to play a part, whether that's through science and technology and STEM, or whether that's through art. Everybody can play a role and take inspiration from things like coral reefs and things that you care about and run with it, because when that happens, it turns into action. And once you have action, then you're going to make the splash that's necessary. We've got kids that are out there cleaning up beaches more often than the adults are. We've got kids that are speaking out and reaching out to elected officials and writing them messages and saying, look, I will no longer stand for what is happening, and I'm going to put my foot down and take my power, which is more than you think, and I'm going to allow this to move forward, and we are going to make a change, because storytelling and your stories is what's important. My story happened to be captured on footage. I was really lucky. I should have never been in that film. And quite frankly, I don't think that my story is all that different from everybody else. I really like corals. That's about it. That's all I see myself as. But everybody here in this room has something that they enjoy, whether that's elephants or primates like Jane Goodall or like Kevin Richardson and his lions. Those stories need to be told, and you all have that passion that's going to allow you to move forward that way. So tell your story and ensure that what means something to you is going to mean something to somebody else and mean something to the world, because we are living in a very exciting time. It's precarious, but it's exciting. And those stories are what's going to move us forward. We can't put this conversation into the hippie bin anymore. We can't give it to the tree huggers. It's a civil issue. We have to take it as you are hurting us and my future, and we have to give our kids a chance. We got to allow them to express themselves, both in art and science, and we got to let them run, tell a story, and make sure that it's heard. That's all I really have. But thank you guys for listening.
Excellent. Well, thank you. So now we get to have a discussion with Zack, and that was great. So if you have questions, you can put them on cards, and people will bring them up to the front. So while we are collecting some of the questions, we'll just say, amazing talk, Zack. And I myself I love the motto, fail forward fast. So I think, you're exactly right. We should never be afraid of failure. What I was going to ask you while we're waiting for the questions is, you are now a movie star, and this movie has gone somewhat mainstream. It's on Netflix, and so since we want to know a little bit about you even more personally, how has your life changed, and how are you, obviously you can use it as a platform coming around to places like the National Aquarium, but how has your life changed for you, and what's sort of the most memorable aspects of having that platform?
Yeah, it's changed remarkably. It's tough a little bit because it's not what I signed up for at all. However, at the end of the day, if the passion that is seen in the film and my love for corals is going to impact anybody, whether it's one person in this room or 20 people in this room, or just Joe Schmo that's sitting on their couch that just watched Chasing Coral. If it inspires somebody to do something, then that's all that really matters when it's coming back to me. It's obviously done a great deal of change. I get to travel quite a bit. I still get to dive pretty frequently. But more importantly, I think the biggest change is that my relation with students and with people that are interested in these topics has really given me a platform to be able to support and give them opportunity and resources to be able to run and engage with whatever it is they're interested in. That's certainly the big reward on my end of the stick, for sure. I think the other one is social media is a really powerful tool. As much as I might dislike it, it's a huge asset. And you can get amazing thoughts and ideas and collaborations going just by a Twitter post, just by an Instagram post. They seem volatile, but they actually can do a great deal of good, and you can actually make waves and start a great deal of momentum simply by getting your story out there and publishing it to the world to see. And I think that's what's so powerful about the world that we live in today, because we are more connected than ever. Sometimes it feels like we're less connected than ever, but the ability for us to put our ideas and put what's important to us out into the world is at an all-time high, and I think that's absolutely brilliant, and I'm lucky enough to have something to say and a platform to share it on.
Excellent, excellent. Are you planning to do any more films? Either in front of or behind the camera?
No, I am not. I was never interested in the film side of things. If I'm going to go do anything, I'll go get my PhD. But
excellent.
Yeah,
I'm assuming in conservation biology or marine.
Yeah, so what I didn't tell you in my talk is I actually have no formal training in marine biology. That was something I learned in the aquarium world. My work in college was all botanical, so I secretly cheat on my corals with plants.
See, we knew the truth would come out at some point. No, that's great. And just being open to the change and obviously learning. I mean, you're clearly an expert, and I think that's a good message for students too, is you never know where life is going to take you, and take your passion with you. I mean, we did have a question from a student in the audience who submitted it before the lecture started saying, I want to make change on my campus. And you probably hear this question quite a bit, and you've given us some of the answers, but what would be the key piece of advice? They want people to start recognizing, the issue, and they want them to start making changes. So what would be the most effective change on the college campus that they could do?
Yeah, I think for me, the biggest thing in taking kind of like a bigger step backwards is we have put the cart before the horse for the most part. We We've gone doom and gloom, and we never really talked about the solutions before we started telling people to change their lives. And the number one thing that you can't do on a campus or in any conversation is tell people what to do. People are very put-offish and very tribal about their lives and about how they go about them. Provide common ground right off the bat. No matter what you're doing in any conversation in life, common ground gives facts a chance. And if you don't start there and you don't have a really nice conversation with those around you that you might be up against, then you're not really having a chance. And you need to always remember that while you might feel like just a drop in the ocean, the drops around you in the ocean also feel you. You have people in your life that love you, that care about you, that want to hear your opinions, that want to understand where you're coming from. And simply by making a change in your own life, you immediately impact those around you. If you don't buy plastic bags at the grocery store for a few months, when you go with your friends, they're going to, whether or not they understand or want to not use a plastic bag because of the environment, they won't because of you. And that in itself is important because not everybody's into science. Not everybody's going to go down some route and have a big understanding of the world and of the geology and biology, etc. But if you yourself can be a beacon for the people around you, that's what really matters. And so even in a university, you're not going to change everybody. But if you can get a core group around you that wants to do some good and make a little bit of a splash, you will be able to do it whether it's within the group, which is a certainty, but more importantly, that will resonate over into the university, resonate over into the administration, and never think that your voice doesn't matter. As constituents, from a political perspective, quite frankly, your voices usually matter more than adults. You can have a bigger impact and be listened to more thoroughly than anybody else because you're students and you actually have a perspective that is probably lost on most people that have gotten out of college and started their careers and kind of lost that sense of curiosity. Your voice is really loud, and I think that we're beginning to see that in this country, particularly over the past few years. There's a great deal of activism going on, more so than we've had in about 40 years, and all you have to do is be a participant and raise that voice.
Yeah, and you're the largest generation coming up too. So you look at it that way, there's going to be, you have a voice and there's a lot of you in mass. And so with that, we have had somebody ask us about, what is the Teens for Oceans project and how do people in this room possibly get involved in it?
Yeah, so it's an awesome question. Teens for Oceans was actually a nonprofit that I ran by myself, rather not very effectively. Because I was a 21-year-old biologist trying to run a nonprofit who had no idea what he was doing. But now we have a great deal going for us. They actually just released their brand new website this last weekend. So they're finally getting onto their feet and really getting out there. But at the core of it is really similar to the talk as a whole. It's about using media and using kind of this notion of telepresence to make a difference in their own world. So sharing stories, getting the kids that have done amazing things or are going out there and trying to give them another platform to be able to share that impact, be able to share their work, and also provide resources when it comes to the technology and the engineering side of things for any of their projects. So from my understanding, all of you guys in the back have these incredible projects that you're kind of collaborating on this week and trying to bring to fruition. That type of storyline is exactly what Teens for Oceans is trying to do. They're trying to give you guys a platform and allow you to be able to get involved and share that across a spectrum of scientists, engineers, people that work in just the marine collaboration to protect places. So we really just want people to get involved with the program so that we can share your stories, provide you the front and stage setting to be able to push your work farther. So Chasing Coral, as well as Teens for Oceans as a whole, has always kind of prided themselves as not being at the core. We don't want Chasing Coral to be the full story. We want it to be an asset to all of the people doing the great work. We can't go out and make everything happen, and so therefore we want to utilize it in a way that allows everybody, I've met millions of people over the past years that are doing the raddest, most amazing work that you would never hear about. How can we find a place and a space for those stories to be shared with the world? And I think that's what's most important. But more importantly, it is for the youth. It's a space where you can get away from the madness of the world and share your stories with others. It's very similar to the network that you guys have cultivated here at the aquarium.
Perfect, perfect. Well, then I think a lot of you should talk to him afterwards
Let's do it.
to join up. Switching gears just slightly is we did have a question come in saying, could you discuss the role of coral mucus, coral snot, in protecting coral from climate change? And so I would just say to most of you out there, do most of you know what coral snot is? No. So, Zach, please.
So corals can become very snotty for a few different reasons. The first one is just simply touching it. So corals don't want to be, I mean, you go up to somebody and poke them in the chest, they're probably not going to like it. You go up and poke a coral, they usually don't like it either. Most of the time they'll start to produce a mucus layer, which can be a protective agent for predation when it's happening. But the most common form that we see it in, even though the event itself is quite rare, would be during king tides. So coral reefs that are quite shallow can actually come out of the water. I've been lucky enough to see this in Australia, where you have miles of coral reef that are actually sitting outside of the water, but they're covered in literal snot. It looks like boogers hanging off of these corals, and it's pretty yucky looking. But it's pretty cool because that mucus is actually acting as a sunscreen. So once that coral is out of the water, it no longer has that little bit of reflection for UV radiation, and so it actually produces its own mucus layer that can protect itself from excess UV. Just like us, we put sunscreen on our bodies. We don't want to get skin cancer. We don't want that UV to mess with our cells. Corals feel the same way, but instead of going out and buying some banana boat, they actually spew it out of themselves and cover their bodies in it. It's super fascinating. You don't see it really frequently, but it's pretty cool, and it feels pretty cool too.
See, that's something else you learned tonight too. Coral snot. Let's just remember that.
It is literally very snotty.
Yes, yes, yes. And so when you were in the ocean, you know, we have a question from someone who was saying they've always been amazed by the power of evolution, as I think as all of us, and saying other than the fluorescent color changes, have you seen any other examples of ocean life adapting, evolving to our changing planet that you personally, you know, when you were in the ocean on your dives?
Yeah, so I think that the fluorescing, more than anything, is going to be the most visual one that I think is interesting. What we don't tell you in the film, and I'm unaware of how many of you have seen it, but I'm going to assume most of you because you're here. New Caledonia, which you see in the film that had that immense event of fluorescence, actually didn't have as high of mortality rates as we would expect based on the temperatures. So there's something going on there. It's obviously some form of genetic adaptation that's allowing some success rates during these events. The majority of the other evolution when it comes to corals is going to be kind of reading between the lines. So those corals that we talked about in the talk, where you have an immensely degraded reef, but you do have survivors here and there, those corals have some form of evolutionary trait that has been selected, or they have now been artificially selected by this event. Those are the ones that have these really interesting genes that we want to look more into and figure out what made you survive, which of these genes is allowing you to have a higher success rate than your neighbors, and how can we exacerbate that into like a larger scale population. That's certainly going to be the biggest thing moving forward in the coral scientific community. Unfortunately, I think the only other really good example of change that we're going to see from an evolutionary standpoint because of climate change in the ocean is going to be sea turtles. Unfortunately, this is not so much a story of adaptation and hope for the future, but more so about how if we continue to warm temperatures, sea turtles almost fundamentally can't exist into the future because they lay their eggs in a similar fashion to alligators and crocodiles, in which the sex is determined by the temperature of the sand that they're laid in. So the cooler the temperature, the more males that you get, the higher the temperature, the more females. So you could guess that nowadays we've seen some clutches of eggs, both in South Carolina, Florida, I believe Australia as well. You can see upwards of 95% of hatchlings becoming female. So that poses a really large problem when we think about it from a genetic or an evolutionary standpoint moving forward, is if you stop producing the males, obviously that's a dead end for anything. That's the biggest example that I can think of off the top of my head, but corals are amazing. They really have this ability to not only evolve as an individual species, but evolve individually again on an individual reef. So like I said before, corals' morphology is determined by their environment largely, and this is what makes it a very difficult job for taxonomists or evolutionary biologists. Is a coral that looks one way in Australia or even in one portion of the reef can be extremely, extremely different looking deeper or in less flow or more flow. So we get a high flow area, corals tend to become very condensed. They get very bush-like. And if you have a very low flow, they get very irradiating. So you can have very branched out, broad, open space within the coral. And when you look at them, they look like completely different species, yet genetically they can be identical. It's just what genes are being brought upon via the environment. It's a very good question. There's so many different routes that we could take, but it would be a perfect PhD dissertation for whoever asked it. So keep asking those types of questions, absolutely.
Well, or perhaps your PhD.
Yeah, absolutely.
Yeah.
It's at the core of everything that's happening in coral reef science. Is everybody's scrambling to find out how can we help organisms be better,
Right.
Assisted evolution, so to speak.
Excellent. And, what would you say? I mean, I think your picture that you posted talking about people just having fun because science is not boring, and it is emotional. I mean, I think your point was that we're always trying to be objective, but there is emotion in there, and we don't always want to show the emotion. So, what would you say, any type of emotion, scary, elated, any of it, that, I mean, you exhibited emotion in the film, and that got remarked on a lot and drew a lot of attention. But what else happened during the whole filming process that you would say was one of your more memorable experiences, good or bad? Or scary, or
yeah. I mean, there's been a lot of fun. There's been some scary. I think the biggest one that sticks in my head was, I talked a lot about how I truly believe that failure leads to the better questions, and for me, it was my original failure on the project that I think ultimately landed me mostly in the film, which you see of me jumping off of that boat in the lightning storm and flooding that computer. And that was a huge failure. I mean, I literally thought that, like, I just lost my job. What an opportunity I had, and I absolutely blew it. Thankfully, I did make it work, and that failure led to a better design the next time around. But that frustration and I think ultimately sadness during that moment is one of the most memorable for me, for sure. The other ones are going to be like...
Losing one's job does not usually rank up there as a high.
No, for sure. I think the other ones would be like some of the joyous moments, like having a group of minke whales swim up to the boat one day and getting in the water with them. And it's those weird, I think most divers, I think, have these weird moments of euphoria where you almost like snap into this dreamlike state where something almost doesn't feel real. And you just kind of pause and nothing else really exists other than exactly what you're focusing on. And if any of you go and watch the film, the first little kind of montage scene, there's a jellyfish. And that jellyfish is my favorite part of the entire movie, and it's one of my best moments that I've ever had underwater in my life. And I don't have a good reason for it. It was a late night. We had been in the water way too long. The sun was going down. We were already late back to camp. And we were on our safety stop, and there was just this beautiful jellyfish sitting there in the gold rays of the sunset. And I just sat there and we filmed it for like 20 minutes. But it was that moment that was like, that stuck with me more than anything during the film, was like these weird little moments that just kind of like change your perspective or like zonk you out for a little bit and allow you to like be completely present,
Right.
100% present in the moment. That was certainly a very important moment for me throughout the film. And then obviously the bleaching event as a whole is, it's a sense of hopelessness more than anything, because unlike deforestation, like how do you stop the deforestation? Well, you turn the chainsaws off. In this scenario, there's nothing that you can do. You can't cool that water down, and you really can't help them. So you really do have to be a wallflower, essentially. You have to just kind of be there and document it to the best of your ability for everybody else. But you so desperately want to be able to act, and you can't. And that's definitely the hard struggle of the majority of the filming was there's not much that I could do, unfortunately.
Yeah, it's a sense of grief. I mean, you
Yeah.
showed that on that was grieving, for what you were witnessing and seeing, but you were documenting it. And I guess but you talk about hope here, and that's, one of the questions as well is, how do we remain optimistic in finding solutions to solve this problem, and kind of combining another question that came in with that of, where do you find the balance, particularly between economics and the environment when looking for these solutions?
Yeah, for sure. And I don't think that there's a right answer per se, but we certainly need hope. It does nobody any good to, walk out of a film and feel like you can't do anything. We all want to feel like it's important. We all want to feel like our actions have some sense of meaning to the ultimate goals that we actually want. But I think what keeps me the most hopeful, first of all, from the evolutionary standpoint, it is that nature knows no extinction, only perpetual transformation. For us, it's holding up our end of the bargain. Corals will be okay if we hold our end of the bargain. And the second one is, I'll reiterate this again from the previous questions that we've had, is that our current political climate in this country is the best thing that's happened to the environmental movement ever.
That's true.
If it had gone the other way, would any of you marched for climate or marched for science? But more importantly, would those marches have even happened? We have activism right now happening that is the most important time that we could have it. And that's really exciting. Despite any pessimism that people may have about the environment or pulling out of Paris, all of these things, it doesn't really matter, because what we're seeing right now is momentum that we have never had, and there's no longer complacency to just be going on because, well, we just kind of do this. For once, we actually are kind of up in arms and saying, well, hey, let's make a difference. Let's get out here and make a change. I think that's what's most important, and what's so exciting about right here, right now, is drastically different than any other time period that we've had, particularly for the environment. So that's certainly where the hope has to lie. And again, corals are remarkable at reproducing and replenishing ecosystems that they were once on. In fact, baby corals actually prefer dead coral skeletons to land on, which is pretty fascinating. In fact, they do a little like wiggle of their butt. I kid you not, they jiggle, and like they'll find the empty coralite, and you see this little larva, and they wiggle their little butts in there, and they create a brand new coral. It's freaking hilarious. Google it. I kid you not. Like it's awesome. They do this little shimmy, and then they create a new coral. Not only are the corals good at it, but I do think that we are in this spectacular moment in time where we're beginning to think a little bit differently and beginning to try and make that balance between economical value and who we are as a people and what our position is. Quite frankly, I think it comes down to we have to be a participant. We cannot be a superior. But
Right.
there's certainly hope to be had.
there is certainly hope to be had, and I mean, when you see wiggle dances like that, I mean, that
Yeah.
that, you
That
know,
should keep you hopeful
that
enough.
that should keep
The
us
fact
hopeful
that,
enough.
The fact that the hope is coming from a shimmy, I mean, what more could you ask for?
Well, that's right. That's right. Well, and you're clearly passionate. I mean, I think one of your key messages here too is to be passionate, and that's infectious and it's inspiring. And just hearing your story tonight, I mean, when I first saw the film, I just sat there thinking, wow, somebody went out there and they're doing something. And by communicating, that's just so impressive. I mean, I guess I would say is what I always kind of sometimes think about this with people that are really, you know, you're going into corals. It's not something everybody understands, but what does your mother say? Does your family know what you do? That's.
So they didn't really while I was working on the
thought.
project, but yeah. So I was really lucky. My dad, he got me involved in like free diving, and just these awesome experiences in Hawaii when I was a kid. So they're both sciencey people. They both they might not have in-depth knowledge on coral that I think I have, but they're certainly happy. And I know for my dad it's very cool because for him, you know, he was the one to introduce me to that ecosystem, and it's a very special place for our family. My grandparents' 50th anniversary was 2 weekends ago. We spent it out on the Big Island again. So, yeah, the ocean, and it's always brought this awesome sense of love and joy to my family. So it's been cool for me to have the opportunity to pursue it. Absolutely.
Excellent. So definitely bringing the togetherness, the emotion together with the science. That's great. And that's what really equates to passion. So with that, we really appreciate your story tonight. I hope all of the, particularly our youth that are here, have an opportunity again to talk to Zack.
Yeah, absolutely.
And I think they are really excited to move forward now with the political activism. So thank you so much, and with all of your actions on the ground.
No,
thank you so much,
guys
Zack.
for having me.